The crowd got a little lighter, so you run that risk later in the day. Are they coming? So I've got the good start will go early. So the front part of the talk is a little free form, so we'll see how it goes. I just want to thank this group for inviting me here to do this. You know, my background's in geology, and I've had to learn this GIS basically in the dark streets and back alleys. Nobody's ever really taught me to do this, and so I get that chance. We've got some kids we're working with who are actually classic trained GIS, and it's a treasure to work with these guys. And I can't say the word. It's just these young GIS professionals are really going to take us places. So I'm really excited about that. So. I really think that discovery of new oil and gas is going to come out of GIS. It's not going to come out of the OSDU. It's not going to come out of the geology departments anymore. I think it's going to come out of remote sensing at GIS is where I think it's going to come out of. And this is an important talk today. And so I hope I can do it justice is what it is. So I've been working a bit in the Illinois Basin, and the Illinois Basin was a basin it discovered in about 1906. They started discovering oil in it. It really responded well to technology, and that technology came in the 1920s and 1930s with gravity surveys, aeromag. Single-fold seismic. The seismic was wonderful work back then. And what it did is it allowed these companies to come in and do great, large reconnaissance programs over hundreds of thousands of acres. And that's how they found oil. They were looking for these big structures, and they were able to use seismic, and they were able to use gravity and aeromag to be able to find these structures. Well, they found the big structures. As this transient industry is, there's always something prettier and shinier over the hill, and so we leave stuff behind, and then we move on to something else. And so Illinois was not able to participate in the Illinois Basin in the large shale play, and because they didn't allow the fracking. They limited the fracking stages is what you could do. And so all you can do now in Illinois is go back and look for these strat traps that are left. And some of these strat traps, they're not big, 180 acres, 13 million barrels as Tontai. I mean, there's a lot of oil left back in the Illinois Basin. And so we've been running prediction after prediction out there to get this, to try to locate these strat traps. One thing we've been able to do is we've been taking the gravity surveys they ran back in the 30s. All we get are the papers on that. And so what we do then is we digitize them, and then we run them through ARC, and it's just the interpolation on this with kriging. I mean, it's stunning what you could get. I was not ready for the success that ArcGIS has with these old gravity surveys and with our predictions. It knocked it up to a whole nother level on these predictions is what we can work with. So what I have today is my very first prediction is what we're going to show. And it is in the where I'm from in Indiana, the Lima, Indiana field, which was discovered in 1884, the great gas field that really where the gas industry was born was in central Indiana. So it was started as a real estate play that, you come here, you can drill a gas well, you can get all the gas you want. And by the time it ended, they had interstate pipelines. They were using compressors. They were selling by meters. The gas industry really got its start in Indiana. And so that's something we don't really talk about too much. But my project is going to be a second pay in the crest of the Cincinnati Arch. And so we're getting pretty close to this. So thank you for taking the time to listen to this. And now we're going to get on to the actual meat of the subject here. I do like to draw lines on maps. Emily was talking about lines on maps, and I have to do it. You know, you can just, circles and lines are perfect. So how we do this. Esri is the key to it all because that's the platform where all my data ends up, all my raster data ends up there, and that's where the random forest algorithm that we use, we're using their first generation of their it was forest-based. They can't call it random forest because that's got a copyright to it, but it's forest-based classification and regression is the tool that we use on that. We're using satellite and LiDAR data is what it is. So it's important to combine the two. The satellite data, we're using Sentinel-2 and we're using Landsat 9 is what we're using. And then the one thing that really has been helping us is Google Earth Engine. This is a powerful tool that it has no end in sight as to what it can achieve. And once we start adding in these agents to start running Google Earth Engine, these great regression models, we're going to be able to use all of this data and really put it to work for us. So what's changed it lately is the large language models and their rise in the past 2 years. I use Grok a lot, but I use it more for a way to study a domain is what I do. So if I want to look at something in the Sparta Shelf, I'll go to Grok and to find these documents that is just, it's hard to do, and then to actually understand these documents. I mean, these are brilliant people that wrote these, but I just can't keep up or make it, you know. So Grok then takes it and puts it in a format that, okay, I know Chuck can understand this. And so it helps me tremendously on that. We also use Anthropic Claude a lot too. And so all of the programming we do to trigger Google Earth Engine, because it takes code to trigger Google Earth Engine, is done by Claude. And that's where Robert Schaefer, I have to give him a shout out because Robert's out of Texas A&M and he's been working with me for about 1.5 years now, and we go back and forth and work on this. And it's good to have a schooled GIS professional to help me on this. What we found is that there has to be a balance to this to get this thing to work. And I don't judge it by the numbers of what I get. You know, we've got some very good predictions that are 50, 60% accurate is what it is with random forest. And it's about the domain. You need to know your domain, and you need to know what you're predicting looks geologic, and it has to make sense to you down there. And so if it doesn't make sense, you have to go back and you have to work again and try to make it work. So the first thing, the one I had the most trouble with is the variable to predict. This is our question. So my question is this spot indicative of an oil well or a dry hole? So I have to go in and I have to mark oil wells and dry holes. And if you do too many with the amount of data in the training rasters, I overwhelm my machine. And so I have to get them balanced, you know, the same amount of oil wells as dry holes, and I'm finding that 32 seems to work for me. That's the number that works the best for me. If I get more, I used to just throw everything in at it. Okay, the machine is smart; it can take care of that. Well, my machine is really stupid. It just can't do that. My thermos and my machine are about the same thing. You know, my thermos can keep hot things hot and cold things cold, but it doesn't know what's hot and what's cold. And same thing with the machine. It doesn't know what's going on with this. It just has a mathematical ability to help me figure it out is what it is. So here's an image of one of my variable to predicts. This is down in Medina County, Texas, on the Austin Chalk. And so I have 32 oil wells and 32 dry holes. And it's just a real binary choice on that. So a balanced variable to predict is very important. So now we go to the algorithm, and I'm using a random forest or a boosted algorithm, mostly random forest. And they say, Chuck, there's better, stronger, fancier algorithms, but random forest is so good at trends. And that's what I'm after. I'm looking for trends. I'm looking, okay, how does this make sense? And it's a simple thing that has worked for the past 20 years, and it will continue to work. And here's what it is. It's a majority vote is what it is. So if you were to ask 1,000 people who's going to win the Super Bowl, you're going to get some opinions on that, and you might see some trends on that. So if you were to ask 1,000 football players, you're going to get probably a better quality answer on that. Say if you wait till before the playoffs start, who's going to win the Super Bowl, you're definitely going to get better information. So it's about getting good information into your algorithm to make these majority votes. And so the beauty of random forest is it is random, and it allows it doesn't overtrain as easily as some. So if you're getting 100% accuracy, oh, shit, I'm overtraining this thing. So you got to be real wary of that. And so, like I said, your results go back to what you know geologically in your mind. Now the training rasters, this is the information. This is the satellite LiDAR data that we're getting and putting in. And this is what we have to put through Google Earth Engine. We collect it with Google Earth Engine, and then we refine it with Google Earth Engine. You look at band 10, the thermals, is which we use a lot. It's a big band, and there's a lot of data in there that you have to work with Google Earth Engine. And then on Sentinel-2, same thing. You just have to divide it up, and then you're taking smaller pieces and find out which pieces work the best. And that's one thing the algorithm does. It lets you know what works the best. So, like I said, we're using Landsat 9, Sentinel-2, and Airborne LiDAR. Okay, in the central Indiana area, we only use 3. And we're going back to Lloyd Fonz's work with land surface temperature, where the oil zones actually act as an insulator, and you can spot then these little cooler spots on the Earth. I worked with Randy Billingsley, who's with Shell and with another group, and we figured out that the biggest signature we could find in this area we were working in central Indiana was stream density, he ran this huge Aeromag survey. And the best thing was stream freaking density, and it goes to where the surface of the Earth and the subsurface are connected, is what it is. And that's why this group is going to be so good at this, is because I think you can understand that the surface of the Earth is a geologic layer, and it's an important geologic layer. And we as geologists, we used to know that, but we've lost that now. We just don't. Well, there's erosion, Chuck. I said, well, the erosion. But anyway, that's another talk for another day. But what I've done then, instead of stream density, I've changed it over to flow accumulation with LiDAR, which gives me the same work. And so what we do then is we put LST together, flow accumulation, and then we'll go through, and then raw band 10 seems to work on us then too. It just has to have that raw band 10 in it to make these predictions work. Then one thing that Esri has done, that they have a predict to raster. So what I can do now is I can take this prediction and then I can put it into raster format. And with raster format, all the tools that Esri are open up to me, and what we can do with it. The filters, it's an amazing thing. So let me show you. This is the predict to raster. So each 10 by 10 pixel is either a yes or a no. Is it an oil well? Is it indicative of an oil well, which is black, or is it not, which is red? And so then we work with this, and I can do multi-county areas with this. I've done up to 5 counties, and so you can actually get this. You can get this technique as a reconnaissance tool over a large area. So here's my Alexandria Second Trenton oil pay project. So there was a great oil and gas field in central Indiana that was abandoned by 1906. And this is just the oil side of it. Down in the southwest is the Illinois Basin. And up in the north central part is the oil side of the Lima, Indiana, on the Indiana side. And so we're looking at this little area right here. And you have to remember, this was my first prediction. This is my Wright Flyer predictions, this one. And I worked 2 freaking months to get this thing to get to where it worked. And I went to the AI Tinkerers meeting, and they were extremely helpful to me to say, Chuck, if you go look in this direction, you will probably be able to figure out what your problem was. And my problem was the variable to predict. I was throwing too many in, and it was unbalanced. And I was also throwing every raster I could find to make this thing work. And it was after this I realized, cut it back, 32, use only your best data, the smallest amount of best data you can do. And then we got this thing to work. And I can judge this because I know the area geologically. And there's, there's our lines. So, but this line, right, we don't have the map. This one, we look at this line right here. That is the Fortville Fault. And I knew the Fortville Fault was there. So if we can image the Fortville Fault, then I know we're on to something. And so that's where you know your domain, and then you can judge whether your algorithm is making right choices or not. All right, and what I still like to do is I like to draw shit on my map. So I went in and I drew all the, I took all the blacks, and then I put the green over the top of them so you can see it. And so I can take out my my prediction, and then I have the my presence laid out. And now this is the LiDAR map is what this is. And lately I've been using Aspect. And I like Aspect because I can tune it. I can look at it a certain direction. This one's not really tuned. What it is it's 270 iterations of blue. So it's light blue to dark blue. So it's not up and down, which, you think lighter is up, dark is lower, but it's not that. So it's just the direction of slope. And then you lay this thing in here, and I've marked where the Fortville is, but I've got a wrench system that is heading northwest southeast, which is, if you know your wrenches in Michigan Basin and in Indiana, they run northwest southeast. There's more lines. It's embarrassing. So what I do then is I throw it on top, and I want to show you this. Once you see this and understand it, you just can't forget it. You look at this wrench system going to the northwest, and then you see how these things are laying right in where the restraining and restricting bands are, and then as it opens up. Now I want to go back to the $250,000 Aeromag they ran that they never ended. They abandoned this thing after one well. They went to the Bakken. There was a big battle at that point in time as to what was going on. And you can clearly see the Fortville right there next to that yellow line. And then you can't really see anything on where the wrench system is. Then you throw in your predictions, and you can see how they're lining up with the Aeromag. Now this was our first land surface temperature using Google Earth Engine, and it's cool is darker. Remember Lloyd Fahn's, his theory was that you're going to find cooler temperatures over oil and gas. So we'll put in our zone. We're getting up in that area. You're getting up into the old First Pay oil field up there, and it's a lot cooler up there. And then you look at my wrench system right here. You throw that in. As you can see, you can look at the oils. They tend to lie in the cooler areas, and the hotter areas don't show up in any predictions at all. So that's my presentation today. So I want to say that all data is important. You know, you can't discount data, but certain combinations of data are more important than others, and that's what I want to leave you with. I want to thank you.